Hey guys, this video is a continuation of the previous one. So we will go through one more problem related to expanding and simplifying polynomials. It is again divided up into multiple sub-questions as shown on the screen here. Let's start with section A. The first part says, show that 1 plus x times 1 plus x times 1 plus x squared is equal to 1 plus x cubed. Now, you can always choose to go the long way and expand everything on the left side and everything on the right, then prove that the two sides are equal. But there is a much easier way to do it. We know that anything multiplied by 1 is equal to itself. So 1 plus x is equal to 1 times 1 plus x. 1 times 1 plus x times 1 plus x is equal to 1 plus x times 1 plus x, which is 1 plus x squared. Well, 1 plus x squared is equal to 1 times 1 plus x squared, so that plus x times 1 plus x squared is equal to 1 plus x times 1 plus x squared, which is 1 plus x cubed, and that is equal to the right side. On to the next part. We realize that it's really just a modification of part 1. Well, it wouldn't be very smart to start all over again, so let's use what we already have. Essentially, we know that 1 plus x times 1 plus x times 1 plus x squared is equal to 1 plus x cubed. So that plus x times 1 plus x cubed would be 1 plus x times 1 plus x cubed, which is equal to 1 plus x to the power of 4, which is the right side of this equation. With section B, it is asking you to come up with essentially a general rule where the sum of everything is dependent on the letter n and x. On the screen, I have summed up everything we have just proved. The third row is an extension of what we have done, and really, you can keep adding new terms to the equation, and the rule that we will prove in this moment will still stand correct. Observing the three equations we have, we see that the exponent of the term on the right, so 3, 4, 5, are all one more than the corresponding final exponent on the left side of these equations, that is 2, 3, and 4, respectively. For your convenience, these have all been circled in black on the screen. We now arrive at the conclusion that for any positive integer of n, the value of 1 plus x times 1 plus x, all the way up to x times 1 plus x to the power of n, should always be equal to 1 plus x to the power of n plus 1. For an extension, you guys are welcome to try and justify this rule and say why it works, just like you would in a pattern investigation project. The second question in section B is shown on the screen. Let's go back to the general rule we just came up with. We know that the entire left side of the equation is equal to 1 plus x to the power of n plus 1. Therefore, we have to find out under what circumstances can 1 plus x to the power of n plus 1 be positive. Well, the given limitation to this problem is that x must be less than negative 1. Therefore, 1 plus x is less than 0, so it must be negative. Well, when a negative number is brought to a power, the result can be both negative and positive. In order for it to be positive, we know that the exponent, in this case n plus 1, must be even. So therefore, n must be odd. An important note, though, is that this isn't always the case. As you progress further with your learning, you will find that there are exceptions and that there are other cases for n which could result in a positive value. However, since this video is intended for grade 8 and 9 students, the answer we have arrived at is sufficient, as further content may not have been taught yet, so this is fine for this problem. Okay, we are almost there. The final question asks us to find the value of the left side of our generated formula, so the one we've been working with this whole time, when the exponent of the final term on the left side is 5. Be very careful here, though. There's something different about this particular expression compared to the previous ones. This expression simply says x plus everything else, while the expressions we've been working on prior to this one all featured 1 plus x. Therefore, the answer for this particular problem should be 1 less than what has been the case previously. Back to the problem. Well, the exponent on the right then should be 5 plus 1, which is 6. So 1 plus x times 1 plus x plus all the way up to plus x times 1 plus x to the power of 5 should equal 1 plus x to the power of 6. Well, it also tells us that x is 2, so 1 plus x should be 3. And we can easily calculate to find that 3 to the power of 6 is 729. As we've just stated, to get the correct answer, we have to subtract 729 by 1, which would give us 728. Hence, 728 would be our answer. Whew. Thanks for hanging in, guys. This marks the end of our 2 lessons on expanding and simplifying polynomials. Hope you've enjoyed these 2 videos and more importantly, that you've taken something away from them. Please like and subscribe to this channel and see you in the next video. Bye then.